Okay, so I've let you all create your favorite function, which you've said is f of x and y is sine of the quantity x squared plus y squared. And apparently we're going to try to evaluate this at 1, 2, comma, what you get when you plug 1 and 2 in, right? Which is sine of 5. You don't get a choice on that. So, how do you do this?
So we need f of x, or we need fx.
Okay, so I need the partials first.
Alright.
Okay, so what's fx at x and y? How do you do that?
Cosine x squared plus y squared times 2x.
You guys all buy it into that?
Sweet.
Yeah. Why didn't there get to be a y out here?
Because y is a constant.
Okay, that's y is constant. Good. And you're sure the derivative of sine is cosine and not minus?
Hold on, can we
We're
write it
not
out?
doing integrals yet.
I have to write down the 4. Is it like cosine?
Cosine minus cosine.
Okay, yeah.
Okay.
Yeah.
Alright, we're good. It's definitely cosine because we're doing derivatives.
Yeah.
How about
then-
fy at x and y? What do you get?
Same thing, only with 2y.
Same thing but with 2y? Yeah, that's kind of convenient, right?
Yay, chain rule.
Yay for the chain rule. Appreciate the one-dimensional chain rule while you have it. When I give you the two-dimensional one, you will not appreciate this thing. Okay, so I got this. What do I do with
Sanity is
this
taking damage.
information?
Those are the slopes.
Okay, those are wait. Those aren't slopes, those are functions.
We have to plug in points.
Yeah, I need to plug in the numbers, right?
Oh,
So they're
Yeah.
equations of their slope.
Yeah, make sure your slopes don't have x's and y's left in them, right? They should be constant. So there's an easy check for this. When you get to the end, it should look like number plus number x plus number y, right? There shouldn't be any crazy functions or weirdness that you're doing to x's and y's. It should be just a single x and a single y. So my tangent plane to x and y is,
Sine of 5.
Function AB.
okay, so you got to start with sine of 5. Right, that's f at a and b, and then you need to add, okay, what's your x slope?
Cosine.
Cosine x squared plus y squared.
Okay,
Cosine of 5 times.
times
10.
2.
No, sorry.
yeah,
two.
so cosine of 5 times 2, right? That's what you get when you plug 1 and 2 in here, respectively.
Right.
And then
Yeah, your
cosine
twos
of
look
5
like those
times
partial
4.
things.
Well, no, you need x minus 1 after that.
Okay, good. So that's my slope, right?
Yeah.
And then I need a change in x, and then I need to add to this what?
Cosine of 5 times 4. Y minus 2.
Okay, so where'd you get cosine of 5 times 4?
2 times 2.
Okay, so we plugged 1 and 2 in for the x and y respectively in the fy, right? And then y the y minus 2, what's that thing?
It's delta y.
That's your delta y. Okay, and if you multiplied this out, right, you'd get
Nightmares.
a number here, and a number out of that, and a number out of that, and then you'd have a number times x and a number times y. Good, I'm linear, right? So x is to 1 power and y to 1 power. Cool. Check.
Can you write the general in?
The general. What do you mean?
Like without you plugging everything in?
Oh, yeah.
Yeah.
Absolutely. So the thing I'm thinking when I look at this is I'm thinking the linearization of x and y at a and b, right? Maybe I should tag this linearization like linear sub a and b, right? And so this is f at a and b, right? Your starting height. Add your x slope at a and b times the change in x plus your y slope at a and b times the change in y. Cool? Okay. Awesome.
So in this case, even though sine of 5 is like undefined, right?
What?
Or is that, is, or no, in the z, Wouldn't that be on the sign?
Sine of 5?
It'd be sine of 5 radians.
Yeah, sine of 5 radians
like-
is just some
That'd
horrible
be like
number.
It's
2 pi. 2 pi
negative
minus.
0.3.
Yeah, it's not convenient, right? But I do know what
Jonas
5
picked
is
it.
an
Yeah.
angle,
Yeah.
right?
So you have to do it
Let's
if I
see,
pick
so pi is 3.14, crap, so I have to go past pi. And let's see, I'm going to pass 3 pi over 2.
it. Yeah.
Yeah. 3 pi over 2 is less than
So it was like
9
close
halves,
to
or a
7
little bit
pi
more
over
than 9
4.
halves, right?
Yeah.
So sine of 5 looks like there's the angle 5, right?
Close to 7 pi over 4 is what I'm saying, yeah.
Yeah, and then sine is which side of this triangle?
It's the x. Or the
The y.
y. Yeah.
Yeah, so here's sine of 5, provided this is 1.
Well, sine of 2 is undefined. I just can.
Sine inverse of these things is
Okay.
undefined.
Okay.
Sine forward is defined.
It's
The
defined. for
domain of
all.
sine is all real numbers. The domain of sine inverse is everything from -1 to +1.
Okay. That's what I thought.
Integer.
For tangent, is that true too? I'm trying to think.
Tangent is a touch funky.
Is it negative
So,
2 to 2?
Tangent's domain. Let me turn it.
Or pi?
Oh, what the
I
hell?
didn't know.
So, tangent's domain. How about this for tangent? Here's a unit circle,
Yeah.
really poorly drawn. When you take tangent of an angle, you're asking how long is this?
Okay.
And so that works, right, as long as I'm between minus pi over 2 and pi over 2, not including minus pi over 2 or pi over 2. And then you can make a good argument for that continuing.
Okay.
So the domain for tangent is all real numbers minus odd pi over 2's.
Yeah. I haven't seen it visually like that before, so it's.
Oh, really?
Yeah.
Oh, cool. Yeah, it has a nice visual interpretation. They all do. They all came from freaking. What's this thing? There's a little
Protractor?
instrument that looks like
The
a
compass?
You call it a compass?
No, it's not a compass.
It's a compass or a protractor?
Looks like this.
Oh,
It's
that-
a sextant.
Yeah, like
I think
the
so,
sailors
yes.
use.
Yeah, they all come from sextants. You can find them all on a sextant somehow.
Oh.
So, they're all there. Cool. Other questions?